Hey there, I'm B. Today I bring a new Unreal Engine 5 tutorial. This time is about subsystems. Subsystems are elements that we can create in any of our projects to create modules, different models that we can use across different maps, anywhere we want. They are very useful because they are not attached to any actor or any other element, and they basically work as a static elements. They are incredibly useful if you want to create, for example, a save system, which is the example we are going to create today, or others like an audio system, setting system. You can use them for multiplayer to get models to start elements in multiplayer, or you can create them to anything you can imagine. Just a test module if you want to test something, analytics. They have lots of different uses and they are very useful, especially if you want to have a common functionality among different projects, so you can bring different functionality to different projects that work similarly. For this example, we will use the project copy Subsystem. This will be available. The link will be on the description below. And here I have a main menu map with a widget. If we open the level blueprint, I just create the widget. It is this one. So we only have 3 buttons: create new game, load save games, and the exit button. I'm going to show you first how the save system look like. So the good thing about them, because they are not attached to any actor or any other elements, we can just right click and just get the save system and it will be there. It works similar to the game instance, so they are very handy, and anything you have inside here public, you can use them. So for example, I have this create new save game with an event. I have this create new save game public function that I can just plug here, so I don't have to initialize, have an object or anything like that. So they are very handy for that. There are different types of subsystems that we can create. There is one that extends for editor, another one that extends from engine, another one for local player, and finally the game instance. All of them are described in the documentations that I will leave on the description below, the formal documentation of Unreal Engine. The one that we are going to create will extend from game instance, which is the system extends from there. So to do that, it's very simple. We just need to create a new C++ class. So right click in C++, all classes, and then we just have to look for game instance subsystem. It's right here. Here we will just we'll give it a name, say subsystem, for example. I already have one, so it's not gonna let me create a new one, but you can just create that and create class, and it will generate everything you need, the H file and the CPP file. As soon as you create this save subsystem or any other subsystem and everything compiles, you will be able to have access to that class. So you will be able to save subsystem and get the subsystem. And the good thing about this, you can access this from anywhere. That's the good thing about it. So for our save subsystem, we will have 2 main functionalities: save new game and load games. Load save games. For this example, I decided that the save system will only allow to create maximum 5 save games, and that's it. That's all. So if I show you how this is currently working, if I click on create new save game, it will just show me the name of the save game, the date creation date, level, and coins. This is just elements that I added to my class for the save. And right now we'll have 3 because I've been testing earlier. But if I load save games, I have 3, the one that I just created and 2 more with when they were created. Let's take a look at the code. So first thing first, my save subsystem will extend from game instance subsystem. That's important. And it will have basically 2 main functions just from the start, the constructor and this initialize. These 2 are important, especially this one, because this will allow us to initialize this subsystem. Subsystems are initialized as soon as we press play, so they are alive very soon. That's why they are so handy. Let's take a look at these 2 functions. So we have the constructor that does nothing, and the initialize. I have this log, so I can see when this subsystem has been initialized. For the subsystem, we're just gonna need 2 functions that we can call from the blueprint. That will be the create new save game and load save games. We will also need 2 delegates. They will be handy to check when the save has been created and when all the save games that we already have has been loaded. That's why I have 2 multicast delegate with 1 parameter, which will indicate if everything went well or not. So we have one for the when one save game was created, and another one with all of the save games that already exist will be have been loaded. And here we have the blueprint assignable and blueprint callable declaration of those delegates. So we have here the save game completed and load all save game completed. They are blueprint assignable and blueprint callable because I want to use them from blueprints, but they can be also used on C++ classes, as well as these create new save game and load save game. They are public and they can be used in other blueprints or in C++ classes. So for the create new save game, first thing first, I have this save game definitions.h file in this project, and this is a simple save game object that I'm going to use for this. You can have wherever you want. This is a very basic save game just to show the example. You can add here as many things as you need. So we have the save game name. This will be the save file. This can be useful if you need to check what type of the file name that you have. That's what I have that there. The creation time is always useful. This can allow you to sort the save games in order when they were created, and I have these 2 variables just to have something for the example of levels and coins. Now let's go to and check how this create new save game function works, and it's very simple. So one of the things I have is this const variable. This is because all my save games are gonna be called Subsystem save game with an index, which will go from 0 to 4 because I only allow 5 save games in this project. So this is the declaration, and here I have the string. I also have the maximum save games, which in this case is 5, but you can add as many as you like. So the create new save game. So the only thing I'm doing is just check what's the next available save game that we can use and use that one. If we already have 5, this function will stop. In that case, you can do something like override or show an error message or something like that. In this example, it's just gonna return false and that's it. But basically what I'm doing is this is gonna be the next available one, and I just have a for loop with a maximum of 10, and it will start on 0. So I'm gonna form this string with the subsim game. So it will check the first one, the index 0, and with this function it will check if that one already exists. If it exists, it will go to the next one with the next index. If not, it will take that one and it will finish. One important thing here is we need this to be always the same. This is an index that Unreal uses to have like the same profile for all the save games. You change this every one, it's like having different profiles or different users. So I have this variable as well as constant. Oh, well, it's declared here and it's always the 0 one. So when it finds, for example, if we have 2 save games, that will be Subsystem save game 0 and 1, it will check the third one, and because that one doesn't exist, it will take that as next available save game, and it will finish it will not find anymore. To check if a save game already exists, we can use this gameplay statics function. Does save game exist? This is part of Unreal Engine, and the include for that is the Gizmet gameplay statics. I have this boolean here to check if any available save games, if any save games are available. So it will be false, and in case if we find one that we can use, it will be true. So if there is no any available, I will just use the event that we declared earlier with false, and in that case you can show an error message or whatever you want. If we pass this point, that means we can create the new save game. For that we can use the create save game object from gameplay statics, and we can store that in a variable which is I have declared here, this one, and it's a pointer using the object ptr with my class save game class, which is this one. So if this exists, this is not null, we can just initialize this element. So as you can see, I'm just taking the file, the save file, the creation time, I'm just giving a level 1, and I'm just giving random coins. After that, we actually, so this part is just creating the save game. We need to save it on file. For that, we can use this async save game to slot, and because this is async task, we need a handle function. In this case, I have handle create new game completed, which is also declared here. It has to be a new function, and it needs to have these parameters. It needs to have the slot name, the user index, and if it's success or not. So we can bind that object to this subsystem, and then we can use it here. So the delegate is declared here. We bind this delegate to this, and we use it with this function. So when this happens, this function will be called when it's finished, this one. And if we go down here, we can check if it has been success or not. And we can just send our save game create completed with true or false. Let's take a look at how we can use those functions that we just created in the widget from before. So I have my widget here, and if we take a look at the on-click button on create new game, we have the canvas, and in this case, show you how that looks like. Is we can first, we want to pin the event to save game created completed from the save to system. So as I was mentioning before, it's very simple to use. So we have the save to system. We can do the event to save game created completed. That's gonna be useful to know when that completed. And finally, we can just create new game, new save game, because they are both public, we can use them. And as soon as this event finishes, we can just do things like, well, we should unbind the event so we don't have lots of events created, and we can just do something like show the information. I'm just gonna remove this and leave it as I had before, and I will show you. Currently I have these 3 save games, so I'm just gonna show you one more. So it will create Subsystem save game 3. That's gonna happen as soon as this widget will be shown as soon as this one is completed. I'm not using the success because I don't care right now, but you can use this one to show a message indicating that it went well or something else. I don't know, that's up to you. I just have a different widget with showing the information. You can take a look at all of these on the project files if you wish. So this is how it will look like, and I have this button that it will let me to go to the game, but that's out of the scope of this project. So as you can see now, this is the last one we created and it's there. So I only have one more. After that it won't create more than that, because I said earlier that I only want the player to be able to create 5. That's up to me. Every developer does it in different ways. Now, similar to save game, I'm gonna show you how the load game works. It's very similar. So if I use that button now, the load save games, it will show me the same list from the list of save games that we have there on the folder. And if I go to the button load save games, I'm doing something similar. So I have an event. Again, I have an event that will let me know when all of the save games that exist on my folder have been loaded, and I just call the load save game to start the async task. And after this has been finished, it will launch this event. I will unbind that, and I do the same. I just switch to a different widget and I show the list of save games that I have. So let's take a look at the code. For the load save games, as I mentioned before, this is the event that I'm gonna use to know when this operation has finished. I have here the declaration, which is blueprint assignable and blueprint callable. And I also have the blueprint callable function load save games. It's in a public section. That's important, otherwise we won't be able to use it in a C++ class or another blueprint. As with the new creation of a save game, we also need another U function to handle every time we load a save game. Because what we are gonna do here is we're gonna loop through all the possible save games that we have. We are gonna async load each one of them. So this function will be called every time. Then in this case, we need to keep track of how many save games we loaded. So for that, we have a list that we will store the possible save games that we can load, and the next slot to load. Then finally we have a list of save games list that we will be storing as soon as each of them has been loaded. You will see how this works, and it's very useful to store this information here because we can access this from C++ class. I will show you in a little bit. So let's go to the load save games and I'll show you how it works. So the load save games, simply first I'm gonna empty the list. This is just in case there is anything inside there. So we have 2 lists. One is the save games file names, and the other one is the actual save game objects. well, the other way around. So we do the same as when we create a new save game. So this time we're gonna check if it exists, and if the file exists, we can load it after that. So we're gonna take again the max save games. So this variable is very important for that, to keep track of all of them. Then I take again this variable around here, because that's the name of the save game, and the index. In this case, it will start with 0, and if that one exists, it will be added to this list. And that's gonna happen for all of them. For example, if we have 0, 1, and 3, it will put them in this list, and it will discard the rest of them. Well, I have a log here, it's useful to have this kind of information so we can see what's going on. Next thing is I initialize this. This is gonna be the slot of the save game that we're gonna load next. And a sanity check here is to check if there is any save games to load, and if there is none, we will just send this, okay, this has been completed, in this case with true, because nothing went wrong, so just nothing, there's no save games. And we will have the list of save games to check later, so we can check that list later. If we pass this point, we can start loading the first one. So we're gonna do something similar. We need a delegate for loading. We can load this we can bin this the delegate, this function, the handle load save game completed, to this delegate, and we can use in this case async load game from slot from gameplay statics using the next file. So in this case, it will be the first index, and it will be subsystem game _0. That will be the first one, probably. Again, we need to use the current user index, so that's important to keep the same one, because if we change this, it won't find the save game. And finally, we use the loaded delegate for that. So when this first one, so this is gonna be only just the first one, we'll call this function, and if everything, and if this save game is not null, we continue. And now we can just cast this generic one to our type. In this case is main save game, which you remember is this one, our one, not the generic one. This is the generic one, this is our one. After that, we just add this to the list so we can access that. And because imagine we have 3 that we want to load, we need to continue loading the next one. So in this case, we add 1 to the index, and before we continue, we just check if we loaded all of them. So if we have 3, this will go up to 3 indices, and we will do the same. We will code the same function with the same current user index and the same delegate. So this is like a loop, similar like a loop, but in a sync. This is the only way to do this. There is no way to use a for loop for this because it's a sync, so it needs to be handled in a different way. When we load all of them, so in this case, let's say we have 0, 1, and 2. At some point, this index will be 3, and this means we just load all of them, so we completed everything and we finished. Now let's go back to the blueprint, and I'll show you how it looks like after we finish this load save game completed. So here, if we load save games, as you remember, I already have 4 in my folder, so we have all of them. Nothing is going to happen because there is no implementation for this, but in this case, the player will click on this and it will go to the save game that corresponds to this. But in this example, it's just this. So as I mentioned before, this is the load save game button. We have the event. This will be called when all of them has been saved. In case there is none, this will be called anyways, but with anything on the list. One thing interesting about this is, let me show you this function that I created for this example. The interesting bit about this is I have this vertical box in the widget. So I have this switcher with these two widgets, the save one, save game, and the load. This is the list, and I'm gonna load all of the save games that were saved. I have this message that I think I'm using to show that there was no save games. But the interesting thing, because this save system has the save game list public, I can access to that, so I can check if there is anything to show or not. And as you can see, I can just loop through that and show every element, just create different rows, different widgets with the rows, just add this information and show all of them. And if there is no save games, I can just show that error message. So yeah, that's very cool to have that information there. So as I was saying, for example, if something very interesting about this save system, if the player decides to load this one, click here and just store that in the save system in a variable, we can access that everywhere. So for example, we could do something like save system, then save game. So I have this one which is from the save game created, but we can reuse this one to say, okay, the player selected the index 3, so we're just gonna get that reference from here. We could do the last. I'm not so sure we can set that, but we could have some kind of function to set this variable from the index that we want. And the cool thing about this is we could go to, for example, the level blueprint and do this. Save subsystem and get last. We can get that. We will have that reference without doing get the elements. For example, we can access get the level or get the coins. So it's very, very handy. This save system is available everywhere. So it's interesting. This is something I started to use a while ago, and it has been very handy, especially for the save system. A few others that are very handy are audio system or music system. The settings are quite interesting to modularize this way. Because you're gonna have settings on the main menu and probably on the game itself. I don't know, there are tons, analytics for example, or there are others. So take a look, and I hope this was helpful and you enjoyed the tutorial. So see you next time. Bye.